So, my name is Reece Sharpe, and I selected the Supercharger testing project for my dynamics project. The first thing that we need to look at is the problem presented. So, as is stated in the paper, the Eaton Supercharger testing cell is squealing, and the belts that are being used on it are wearing much earlier than they should be. So I analyzed the problem and was able to narrow it down to 4 key questions. What's causing the squealing and the wear? What new belt and tension should be used on the supercharger for more optimal performance? What's the factor of safety of this new setup? And how many cycles can we expect so that they can know how many belts they need to buy, as well as how often they're going to need to replace them? So, looking at the first question, what's causing this? So slipping is generally due to under-tensioning. Either the belt is too long, not too tight. As seen in this figure, you can see a drooping of the black line that represents the belt between them, whereas the dotted line represents a straight line that should be more optimal for this pulley setup. And so this figure represents under-tensioning that can cause slippage. So, looking on to choosing a belt, one of the most important points of it is the effective length. So I was able to go through calculating the total length of the belt needed based on the pulley system given and the diagram presented. So I did make a couple of assumptions to help ease the calculation. I was able to essentially make it so half of each pulley I used their circumference, and the rest was just freeform connection of the pulleys, generally subtracting the distance between them and their radius when necessary. So some other important factors that are when choosing a belt are the price. We need to try to choose the least expensive for what we need. The lifespan, we are going to want to try to get as much life out of this belt as possible. It needs to be a good fit, which is why I've calculated the length, and it needs to be available. They specifically stated they do not want a special order. And as is also stated in the problem, the belt needs to be designed for a pulley system that uses 10 or less ribs. So, after going through a number of belts online and checking their specifications, the best choice that I came to was the Gates Micro Belt, product number 070880. It has an effective length of 2235 millimeters, which was 1 millimeter greater than the 2,234 millimeters that I calculated in my previous slide. The price is $43.99, commonly available with a standard lifespan and a rib number of 7. And the good news about this is that its tension setting is 105 pounds or 467 newtons, which is well within the 490 newton tension setting that will be in place for the belt drive, which, since the only forces will be the tension applier and minimal forces of friction due to mostly air contact, minimal physical contact, and low weight, we can rely on this for our tension setting. So some alternate belts that I did look at, these were the other 2 top contenders, were the Micro V Aramid belt, which had a similar performance to the standard V belt, but at a slightly higher price, which is why I did not go with it. Then there was the Fleet Runner Micro V belt, which was casted as having a much longer lifespan and higher durability, but I was not able to find any specifics on that, and it had nearly double the cost, so I decided to stick with the Micro V belt. Looking at the lifespan of the belt, I was able to use some dynamics equations to calculate the speed of the belt, and then looking at the general lifespan of the belt using a high factor of safety of 20,000 miles. After some conversions, I was able to work it out to 173 work hours of the supercharger being active. And with that, I was able to complete my project, my sources for pricing, belt information, whatnot. Thank you for watching.